Hi, my name is Muhammad Zulaini bin Azman. I will begin our group discussion by explaining the introduction first. First thing first, we must identify what is the use of house price index and how it is important to all residents, especially in Malaysia. So, the Malaysian house price index is an important indicator used to understand changes in residential properties prices in Malaysia. It provides valuable insights into the price trends across different states and type of property. The index is also calculated using a weighted average approach, considering factors like location, property, type, and size. This index is widely used by policymakers, investors, researchers to analyze and study the housing market dynamics. By monitoring the index over time, stakeholders can assess the affordability, stability, and growth of housing sector in Malaysia. It offers a comprehensive overview of the market performance, enabling stakeholders to make informed decisions and develop effective strategies based on market conditions. Next slide is about our data resource that we obtained to use in this case study. The house price index data that we will be discussing for this case study has been obtained from the leading and trending economic website. This website is known for its reliable and up-to-date information on various economic indicators, including the house price index. The data provided on this platform is carefully sourced from reputable sources such as government agencies, central banks, and statistical organizations. By utilizing this trusted and widely recognized website, we can confident in the accuracy and the credibility of the house price index data. This information is crucial for understanding the trends and the pattern in the housing market, enabling us to analyze the performance of the sector and make informed decisions. This is our data for house price index in Malaysia from 2014 until 2023. The Malaysian House Price Index dataset contains annual data on the index of house prices in Malaysia from 2014 to 2023. The index is based on weighted average of prices of different types of residential properties across different states in Malaysia. This table consists of 10 rows, which is the point, and also 3 columns. Column number 1 are the years of the data point being taken. Second column is the house price index X, which represents the index of house prices in Malaysia, whereas the base is 2040. Third column is the annual change Y, describe the percentage change in the house price index from the same month in the previous year.
Hi, my name is Muhammad Sani bin Muhammad Amin. So I would like to present about the quadratic curve that we calculate it manually. So first of all, this is the data that we get from the previous slide. We want to change this data to the quadratic equation that will be a plus bx plus cx squared. So from this quadratic equation, we want to express it to the metric form that will be ax equals to b. Next, we want to check the consistency. So how we want to check the consistency? We must use RREF process, and we will get there will be a false statement at the row 4. This indicates that the system is inconsistency, therefore we must use a normal system. After that, we want to use a normal system. How we want to use a normal system? We must use the formula A transpose AX equal to A transpose B. First of all, we find the A transpose A, and then we find the A transpose B, and we equal it, and we get the final answer for the normal system.
Alright, Assalamualaikum. My name is Ahmad Shukri bin Muhammad Syukur. So I'm going to continue about the solution or process about the least square solution in order to find the equation of best quadratic curve. We check the determinant for A transpose A, which is for find the type of solution from the normal system that we get before. As shown by the slide, the value that we get from determinant A transpose A, we got the 4.55096 times 10 to the power of 14. So from the value, we can conclude that the system has a unique solution. So we move to the next slide, which is we use the elementary row operation to find the reduced row echelon form. Operation that we use is Gauss-Jordan elimination. We can see that the reduced form, the reduced operation, and the next slide, finally we got the value of A, B, and C for the least square solution, which is A, we got the value of negative 188.1389138, and for the B, we got the 2.246883251, and lastly for the C, the value we got the negative 0.006461614037. As an equation for best fit quadratic curve, we just plug in the value that we get from the least square solution to the equation formula, which is the formula is y equals to negative 188.138 2.2469138 plus 2.246883251x minus 0.0064616140337x squared. So we move to the last operation, which is the error vector. In order to find the error vector, b minus ax, and after we use the formula, we can get the error vector, which is negative 1.803722467, 3.222132106, negative 0.4494633136, 0.0181810079, 0.40124329, negative 1.72179200975, negative 1.36918533, negative 1.158555359, 0.97717725, 1.8801045557. So after we got all the value of the error vector, we also can look out for the error magnitude or the size of error vector. So the formula is cert with the total of all the error vector value. So we calculate it, we got the value which is 4.966895.265. So based on the total of error magnitude, the value, we conclude that the best fit curve is by using quadratic equation because it will give the best approximation as it has a minimum error.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Abang Fadi bin Abang Syahrin, and I will explain more about this project in terms of Maple solution. For the first step in Maple, we need to write down the coding first, which is typed with linear algebra and with plots. All of these coding are important for our calculation in Maple. Next is plot the data points, and this is the result for data point x and y. After that, point plot and linear approximation. If we write down the coding as in the picture, we will get the chart with plot. Next, I denoted A1 and A. A1 is equal to the value of constant x, which is 1. So, we will have 10 numbers of 1. The value of A1, x and x squared. Furthermore, we will have AY and the RREF, reduced row echelon form for AY. And from the RREF, we can conclude that the system is inconsistent. So, we need to compute AT, which is the transpose of A, and the ATA that equal to transpose A multiplied with A. In order to find the value of the determinant A, just type determinant A in the bracket ATA. And for ATB, it is equal to transpose A multiplied with B, and we need to find the value for M. After we get the M, we proceed with RREF for M, and we could get the equation of Y from that RREF of M. Moreover, from that equation, we can find the best fit quadratic curve by using coding, which is B plot Y and X, and the interval is from negative 100 until 1000. And this is the image of graph for best fit quadratic curve.
For the conclusions, the Malaysian House Price Index MHPI is a tool used to monitor and assess the performance of the residential property market in Malaysia. It tracks change in the property price over time, providing insights into the market trends, affordability, and the potential risk. The provide quadratic curve Y equals negative 188.1389 plus 2.24688x minus 0.006461 x squared represent the relationship between the house price index and time. The curve suggests that property prices are influenced by time in a quadratic manner. The error magnitude of 4.966895265 indicates the deviation between the actual data and the future curve. They state that the house price index increase almost every year, implies in a general upward trend in a property price over time. This information is available for buyers, sellers, and also investor. In summary, the MHPI is a useful tool for understanding the residential property market in Malaysia. It provides available information on market trends, affordability, and potential risks, helping a stakeholder make informed decisions.